Okay, so we're going to begin the bivariate statistics today. Like I said, when we say bivariate statistics, we are talking about statistics that involves two variables. Okay, someone is on my WeChat. I'm busy. That's okay. It's our friend, Miss Krista C. Okay. Bivariate statistics involves, we're talking about some statistical interpretation that involves two variables. For example, if you're talking about if you're talking about all of us in this class now, and we're not just describing our ages, we're probably also talking about our height. So you have like person one, age 14, height X, person two. So each person is described in two set of data. Okay, then we can discuss bivariate statistics in that regard. These are the things we will go through. This is everything you need to learn as far as correlation and regression is concerned in IB syllabus. So I'm going to use exactly this. Everything is required. I want us to touch A and B today within the next, say, 30 minutes. It shouldn't take time. So we begin with this. Now, you've done scatter plots, isn't it, from your IGCSE class, right? Can I get some response? You've done something like scatter plot and things like that. So we're going to do it in a more extensive way in this class. And if you haven't done scatter plot before in the past, it's fine. Is Brandon eating shoes? Anyway, two terminologies here. Two main things here. If you look at the beginning, maybe page 707, you can see two main things here are correlation and regression. There is a slight difference between them, correlation and regression. That's what this topic is all about. Correlation refers to the relationship between two variables. Is this relationship a strong one? Is it a positive one? Is it a weak one? Are they even related? That's what correlation does. Regression, however, establishes that relationship. Again, let me come to the board. And I just want to quickly summarize that before we start taking the correlation and regression one after the other. Okay. So the costs, maybe after plotting a graph, we realize that the cost and number of a particular item follow this pattern. Okay. And at the end, we realize our C is equal to maybe AN plus B, where B is this intercept, isn't it? And A is definitely greater than 0 because of the shape of the line. Am I making sense? So you can say, oh, there is a correlation between them. In fact, there is a maybe positive, not necessarily perfect correlation between N and C. So N and C are related. So there is a positive correlation between them. That is what correlation does. Regression, however, tells you that particular relationship, how they are related, like a model, such that if you know any particular N, you can predict a particular C. Am I making sense? That's the main difference between them. Correlation only tells you what type of relationship exists. Regression, however, gives you more information about that relationship, gives you in form of a model, establish the relationship. Do you understand that? Does this make sense? Okay, great. So for today's class on correlation, we'll be talking about some stuff. I'll send you the screenshot of this. I'll send you the screenshot of this page later. So when talking about the correlation, which is the relationship between two variables, there are some things that we want to take into consideration when describing them. The direction, just like the direction of a line, okay? Linearity, is there a linear relationship or a non-linear relationship? What I wrote on the board earlier, ax plus b, is a linear equation, isn't it? So if we model a relationship in using that equation, then of course the relationship between them is linear. Relationship between them could be exponential. It could be quadratic. Am I making sense? But for your level, you're only dealing with linear regression stuff. So linearity, the strength. When we talk about the strength, is it weak or is it strong? You want to also describe the outlier. We talked about outlier in the previous chapter in school, isn't it? So outlier comes into picture again. And we also want to talk about the causation. The fact that they are related, does it really mean that one causes the other? Am I making sense? Because in some situations, as you will see, there may be a strong correlation, a positive correlation between two variables, but doesn't mean one variable caused the other. It could just be a mere coincidence. Does that make sense? Okay, so let's take one after the other. For direction, just remember the idea of your linear equation. If you have this, if this line is this way, your gradient is positive, isn't it? So if you plot your scatter plot, your scatter diagram for your bivariate data, I need everyone to please pay attention and look at the screen. Brandon is looking down. If you plot the data on your scatter plot and you have this direction, then you say there's a positive correlation between the two variables. This is similar to a few things we must have taught you in maybe Form 1 or Form 2. We only care about positive, negative, and no correlation. Then we don't really establish the core of it. Of course, if it goes downward, we say there's a negative correlation between the two variables. And of course, if you can't seem to see a pattern, then it's just a random scatter plot, a point everywhere. Then we say there is no correlation between them. Okay? So again, when describing correlation between the two variables, you want to talk about direction, the linearity, the strength, the outlier, and the causation. I will give you an example later. For linearity, if it follows like a straight line, then you say, yes, the relationship is linear. Otherwise, it is not linear. Can you see this compared to this? Okay, how to get this line, we'll talk about that in later class, something called the line of best fit. We'll talk about that, that's not for today. In terms of strength, it could be strong and positive. It could just be moderate. Strong, if you look at it, the case of strong, they are all close to that line, isn't it? But in the case of moderate, it shows a positive line trend, isn't it? But it's not as strong as this because some of them are far away from the line. And for weak, you could see it is still going towards this, but it's more diverse again. So this is weak. So this is strong, positive. This is moderate, positive. This is weak, positive. Does it make sense? Similarly, negative. It is strong negative here, moderate negative, and weak negative. Okay? Now, in terms of, we know what an outlier is from our previous lessons, isn't it? These two are outliers because they are far away from the data itself. This sort of outlier will be the one we talked about. We said something about discarding some outlier, and some outlier should be considered. Remember that in the previous topics? So this kind of outlier will be discarded. This is still to be considered. It might be far away from others, but it shouldn't be treated as an outlier because you can see it is on the line. Okay, so outliers, again, like we know earlier, they are isolated points which do not follow the trend of the main body of data. So if the outlier is a result of recording or graphing error, we've talked about that. This is the same statement. It should be discarded. However, if the outlier is a genuine piece of data, it should be kept. So this will be kept because it is still following that trend. It might be far from others. Why this is discarded? You may not really need the effect of the outlier now until line of best fits. Okay, but this is just for your information. Now, in terms of this scatter plot in the opening problem, so this is between age and distance thrown. will you say what kind of relationship, what kind of, describe this correlation, anyone, between the age of the children considered or people considered and the distance of maybe a particular object they were able to throw? Anyone, quickly. Come on, quickly.
It's moderately positive.
Is what?
Moderately positive.
It's positive, moderate. We can't say this is strong, isn't it? Some of them are kind of far, right? So we can say, yeah, it's positive, moderate. So there's a positive or moderately positive, like I said, correlation between the age and the distance thrown. Now let's talk about this causality quickly. The idea of causation is what I mentioned earlier. I will look at this. Let's look at this example. Okay, first of all, like I said earlier, the correlation between two variables does not necessarily mean one caused the other. Okay, so let's look at this for example. The arm length and running speed of a sample of young children were measured. A strong positive correlation was found. So when the stuff was put on the scatter plot, oh, there's a strong correlation between them. It's positive. But does it mean that the longer your arm, the faster you can run? Or does it mean that the faster you can run, then your hand will become longer if you can run faster? Do you understand what I mean? Again, does it mean that, oh, if you can make sure you grow your hand to be longer, then you'll be able to run faster? Or does it mean that if you're able to run faster, maybe you go to the gym every day, you increase your speed, and subsequently you are able to also increase the length of your arm? Even though there's a positive correlation between them, this does not, we can't conclude this. So this does not mean that short arm causes reduction in speed, or a high speed running causes your arms to grow. Rather, there is a strong positive correlation between the variables because, look at this part, because both arm length and running speed are closely related to another variable which was not in the picture at first, which is the age. Ethan will probably run longer than someone in P5. So maybe it's a function of age. Do you understand that? Okay, someone in P5 or maybe P4 will probably be in age 10, isn't it? This dude will run faster than him. Brandy will run faster than they are. So while it looks as if the arm length and running speed, one causes the other, it's actually as a result of the age, because of course the age determines, maybe the inner strength or stamina or something like that. Well, not necessarily, because some of you, I'm older than you are. Not some of you, I want to believe, except there's a grandpa in our class. Some of you can run faster than I am. Okay, do you get the point now? Again, this is another example in your book which I find interesting. The number of television sets in London, sets sold in London, and the number of stray dogs collected in Boston were recorded over several years. A strong positive correlation was found between these variables. The question is, does it mean that the number of television sets sold in London causes the stray dogs in Boston? No. Do you understand that? Obviously, the number of television sets sold in London was not influencing the number of stray dogs in Boston, except there is something we don't know. Maybe the aliens can tell us. It is a mere coincidence that these two variables will increase over time. It's just a mere coincidence. There might be other factors. So this is the conclusion here. If a change in one variable causes a change in the other variable, then we say that a causal relationship exists between them. In this case, a causal relationship does not exist between them. So you might have a strong positive correlation and there is no causal relationship between them. And you might have a strong positive correlation and there's a causal relationship between them. Do you understand that? I can only see a few people. Miss K, Nakita, understand? Okay, great. Now, in these cases, we say that independent variable. Now, I've mentioned independent variable and dependent variable in the past. I like to use X and Y to explain it. Of course, we're going to be using X and Y. When you write Y is equal to AX plus B, okay? The value of Y depends on what you substitute for X, isn't it? So Y depends on X. So this is your independent variable. Okay? While this is your dependent variable. Does that make sense? So this is what we mean by dependent and independent variable here. So the independent variable, which is your X, explains the dependent variable, which is your Y. In a more, it may be more natural to use this term. So when you see this terminology, explanatory variable and response variable. Explanatory variable will be your X, the response variable will be your Y. Of course, Y responds to whatever X brings. It determines, Y depends on it, that's what that means. In cases where a causal relationship is not apparent, Brandy, are you here or are you doing something else on your screen? Okay, I just feel you are distracted a little bit. In cases where a causal relationship is not apparent, we cannot conclude that a causal relationship exists based on eye correlation alone. I think this is what I mentioned earlier. So the first thing I want us to do, I put this to make it easier. If we were in school, I'll probably put this on paper, we'll write some stuff, but we don't have the paper. So what I did was to put an activity on the Edmodo. It says for each scatter diagram, describe relationship between this variable. Consider the direction, which means you have to mention whether it is positive or negative. That determines the direction, or maybe there's no correlation. Linearity, you have to tell us that it is linear. Then the strength, is it moderate, is it strong, or is it weak? And is there any outlier? You see, there's nothing like a causal or non-causal relationship here. Can somebody tell me why? Anyone? Hello?
Because you can't see that from the graph.
Why do you think so? There's a particular reason why. Why are we not talking about whether there's even though we have positive or negative, why is this question not asking you if there is a causal relationship or not?
Because that cannot be observed from the graph.
Why do you think it cannot be observed? There's a particular reason. That's the reason I'm asking. Why can it not be observed from these graphs? Anyone? Nice try, Karen. You're right, but I just needed to give more information.
Because we don't know what the actual variables are.
Exactly. We don't know the actual variable. It's just X and Y. What is X? It could be Karen's age and Karen's love for food. We don't know. Okay? So that is why it is not observed. It is not like that obvious from the graph. Okay? Good job, everyone. So please go to Edmodo. Can you see my Edmodo? Can anyone see my Edmodo? Okay, perfect. So where is my, okay, quiz, load, let's load the existing quiz and post it. Load existing, okay, here we go. That should be, today is 12, so I might have used the date, 12 February. Here we go. No. Yeah. Today's Friday. Search was Friday. This is another one, not this one. One sec, please. Should have, as soon as I did it, okay, yeah, here, association with a variable. Oh, I didn't put a date, that's why. My bad. I didn't get enough sleep. 12th February 2021. It's Friday. Happy New Year. So I just put instruction as Happy New Year. Okay, so let me show you a preview of what I need you to do. So like I said, I put it, please don't do what I think you're doing. Reason quiz. Okay. So this is a preview of what I needed to do. So you look at this, you type here A, you describe it, you type B, you describe it, and so on. All right. So remember, I copied the same instruction, talk about the direction, the linearity, blah, blah, blah. Then the other three I put here. Okay. Then here, I need you to look at these two and tell me which one is independent variable and which one is dependent variable. Excuse me. Now, when writing this, because this is like auto grading, write something like hours or numbers, no capital letter, but copy exactly what is here. But because it's continuation of a sentence, use small letter, capital letters, use small letter of what you see. So if your answer is hours worked, you should write hours space worked. Don't put extra space. If your answer is number of workers, write number of customers, just the way it is, with no space after that. Understand? So you do the same here. Then here, I think I use a 3-letter answer. So which day? So maybe Monday and Tuesday, something like this, as you can see it here, not full days. Okay, something like that. What else? In this case, you copy this. This is the statement. Just copy here and paste A and just type in the 3. So here I need 3 different words with comma sign. And here I need the last one here. Does it make sense? Then in the B part, will it be reasonable to conclude an increase in this causes that? So is there a causal relationship, something like that? Let's try to do this within the next 5 to 10 minutes. So let me exit my preview and post it on the page. Let's assign. We can put the due date for tomorrow, so others are not. Of course, I know everyone will do it today, like immediately. So no need to randomize the question. Of course, we don't need 60 minutes. So I just put 15. Try to do it in 5. Okay. All right. So go to Edmodo, everybody. Try to get the other one ready. Would you like me to share those terminologies? Okay. I'll put that on the WeChat now. Okay, we don't need this. I can put it. So if you wish to write it later. I'm going to record the last picture and resend it. Done. So that's all for now. I'm going to pause the recording, and I want those that are not here to pause at this point and complete the activity before moving to, one sec, please. What is this stuff? So please, Lillian and Krista, pause before moving to the next, before watching the rest. So I'm going to pause the recording at this point. We're not in school. So these are the questions you just did. I may send you this information later so you can check it with what you have done. So hopefully you did it right. The second activity that I put online has to do with these two. Unfortunately, I can't find it for whatever reason. So we will do that later. I'll post it later. Okay. Now let's move to this. You see, there's positive, there's moderate, there's this, there's weak, there's that. You know, we have a way of describing it with a numerical value. And that is what we do with the Pearson's product moment correlation coefficient. So that coefficient tells us the degree of that linearity, okay? Tells us that degree. Is it weak? Is it moderate? Is it strong? Or is it perfect? It will be perfect if all the points are on a straight line. They are all collinear. In that case, your R will be 1. That's perfect. Okay. So we're going to calculate this, and you're going to use calculator. You're not expected to do it manually. Although I will encourage you to do this manually as well, but we will use calculator. And I will give you the calculator instruction, so you will do that. Now, these are the properties of this coefficient, this value of R. Okay, by the way, why do we do this? There's a particular information here. Since this method is subjective and relies on your opinion, like what you just did now, oh, it's moderate, it's this, it's that, that's your opinion. So it's possible whatever Karen says might be different from what Crystal will choose to say. Somebody said earlier, oh, it is moderate. Was it Ethan that said moderate? Someone might say, oh, that's not moderate, that is strong. Okay, especially if you don't know what is the borderline between moderate and strong. Am I making sense? So That is why we can actually get a precise measure of this strength using this, okay? So the X and Y are those points, X-axis, Y-axis. So those two, the bivariate data, that's why it is bivariate data. So every data has a X part and the Y part. It's like every candidate has their score in two subjects, math and English, for example. So the X will be everybody's math score, the Y will be everybody's English score, something like that. And remember, each of these subjects describe each of the candidates, just like what you did in the previous activity. You see, each of these jobs has two sets of data. That is why we call it a bivariate data or bivariate statistics. Okay, now, so the X will be the first one. It doesn't really matter. This Y will be the second one. If we are to do this manually, we will do summation of this product, which means we'll calculate the mean of the X, we calculate the mean of the Y, the arithmetic mean of X and Y. That is why we call it X bar and Y bar. Am I making sense? Then we do, this is called what from our previous topic, X minus X bar. This is what's called what? Anyone remember? Start with the word D. X minus X bar is what?
Deviation.
Say that again.
Is it
Is it what?
deviation?
Deviation. Okay, deviation. So this is the deviation of each data from the mean. Each X deviates from its mean. Each Y, you see, this mean has a very significant effect later. We will see later. Deviation from the mean. How does each Y deviate from their mean? Then we will add all these deviations. We square that. We square the other one, we find the square root. This gives us the coefficient we're talking about, but we don't have to do it manually in this case, like I said. Now, depending on what that value is always between -1 and 1. It's never beyond. So if you calculate your correlation coefficient and you're getting 2.5, please go back and check. You have done something wrong. Okay? So the sign indicates the direction. If it is positive, then this is the line. If it is negative, then this is the line. Okay, and what does that imply? It means one variable results in the increase in another variable. So increase in one leads to the increase in another. If you remember the idea of, I don't know, did I teach you guys myself? I'm sure I did for some of you. I must have taught you variation. Remember, X varies directly as Y if as X increases, Y also increases. Do you remember this? This is IGCSE. When we say X is directly proportional to Y, it means X increase leads to Y increase. This is the idea of the positive correlation as well. And when we do inverse variation, it means as X increases, Y does what? Reduces, something like that. Am I making sense? So this is the idea of the correlation as well. So when you get that value, this will be the interpretation that you will share as a conclusion. So if your R is positive, that means an increase in one variable is expected to lead to an increase in the other variable. Okay, and when your R is negative, it means an increase in one variable will lead to a decrease. So that is like your direct and inverse variation from your IGCSE classes. And if your R is 0, it means we cannot establish that both of them are correlated. Understand? Now, depend on the size of R, either positive or negative, then you can talk about different strengths. Again, the sign of R tells you the direction, okay? But the size of R tells you the strength. Am I making sense? So if your R is 0.1, it's different from when your R is 0.9. Both of them are positive, but one is stronger than the other. Is that understood? So, and the closer to 1, the stronger it is, basically. The farther it is from 1, the weaker it becomes. Okay? All right. So this is a summary table to guide you. I'm not going to share this table because the next activity is for you to figure out which one is strong, which one is weak, and things like that. So I want us to go through this table, and I want to test how much you remember about this table in the next few minutes. So it says, when R is 1, it is perfect positive. When R is -1, it is perfect negative, like everything is on a straight line. If you have between 0.95 and 1, this is a very strong correlation. Very, the word very is there. And in the other way, between that minus 0.5, do you understand? This is a very strong negative correlation. Okay? When R is, a little bit far from 0.95, just strong, not very. Okay? Try to remember this. Don't write anything yet. Try to remember this. Okay? It's just intuition. No big deal. I'm just going to give you something like a drag and drop in the next activity. So you drag which one think is more suitable. That's what I want you to do. So I'm not asking you to write anything. Okay? Now, this is not strong anymore. We can say moderate positive. And of course, if it is within this range, then it is weak positive. And this is very weak. So something like this can be used as a guide. And the same thing, this is just like a mirror, the reflection on the negative side. Is that understood? Okay. Now, if you look at this now, the value is seen to be this. There's a weak association between them. It is positive, but very weak in between them. Now, I want us to go back to Edmodo. I'm going to be posting now another activity. I call it product moment activity 1. I'm going to give you, again, 15 minutes, but you don't need 15 minutes. It's just drag and drop. I'll put the deadline to be tomorrow again. It's just drag and drop. So refresh your Edmodo now. There are 4 questions. Actually, the last one is not a question. It's just for you to... Wait, what is this? How many questions can you see, please? Are they 4? Okay.
Yeah, 4.
I think I'm still looking at the old one. Okay, but never mind. You have the correct one. Continue. The last one is just to say yes or no. I've gone back to check, so it's not really a question. So there are 3 questions actually. So I'm pausing the video. So Lillian and Krista should please do this before watching them. Since you missed the last question, Brandy, and it's just yes or no, you won't have chocolate. No one next will share chocolate in the class. We'll give someone extra chocolate instead. Krista, okay, thank you. So we're just going to take one question to do the calculation, and that will be it for the second aspect as well. In the next few hours, I will post some things, maybe like a worksheet also, what you need to return back to school for me. And that's it. Done with the quiz. Thank you very much. Nice. Good. Oh, sleepyhead, Mr. Chang. I hope you don't sleep in the family dinner or family stuff you're going. Just tell them to give you food. Tell them we love food in our class. Okay, so 1, 2, 3, 4, 5. I think everyone finished, right? Krista K is here. Karen is here. Oh, Karen was the first to finish this time. Yay! Oh wait, was that for the previous one? Okay, sorry.
I didn't find the quiz. I just found it
Okay.
because I didn't reload the Edmodo.
All right, it's just drag and drop, so it should be easy and fast. Clary, can you see yourself on the screen? Clarissa, can you see Edmondo? No. What is my screen showing? Okay, sorry. You kind of have like the coolest one, apart from Miss V. Actually, look at, she's like, I'm the boss, making the videos. Like, I'm the boss. I'm so cool. All right, Karen, I'm waiting for you. So let's refresh this and see how many submissions I have. 9, 6. Okay, 1, 2, 3, 4, 5. How many people are here? 6, 7. So just Karen. Okay, great. And 7 is done for this one. Nice.
I just submitted.
Thank you, Miss K. All right, so let's go to the last part. I promise in 10 minutes we're going to be out of here. Sorry. So everyone bring out your calculator. The calculator function will be shared now here. So I want you to try this. These are two data given for X and Y. I want us to calculate the value of R. We are not doing the regression. We only need this, okay? We're not doing the regression yet. So only focus on the value of R, okay? So everyone try this. To find the correlation coefficient of this data, enter X in the list 1, Y in the list 2, okay, and follow these steps. So let me know when you're done with it. You're supposed to get R is equal to minus 0.85. I'll send a PDF format because we have a Mr. PDF on our midst. Done? Tell me when you're done. Okay. Nice. Good. So let me save this and send to us so we can make use of later. Regression. Nice, 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 nice. So if you check our group, so I send a PDF calculating R. For those that will not mind a screenshot, I will also send a screenshot. So it's just going to be picture format. Just a sec. So did you get the answer here? This is minus 0.8 something something. Nice. Okay, so that's a screenshot as well. So we just need to use technology to calculate. Please try to use the formula as well. I will send these pages to you. I wanted us to try to do the formula together at first, but no need to waste time with that. Please try to do it on your own. I trust you can. I trust you will. So I will also send, I'll send these notes so you can have them for later. While I'm doing that, can I ask you to try this problem? Just a sec. Okay, this is part of what you've just done. Okay, can everybody see this question 3? Guys? Hello?
Yes.
Okay, great. Can I ask you to do 3C? You don't need to draw the scatter diagram, just calculate R and describe what you think. So you can just write in your reply, oh, there is a strong positive correlation between X and Y, something like that. Oh, there is a weak blah, blah, blah. Oh, there is a moderate positive. Oh, there is no correlation between X and Y, something like that. So describe a linear correlation between X and Y in 3C. Calculate R with your calculator and send it back to me. That will be our last activity. The rest will be sent to you as worksheets and stuff. You may listen as you do that. The past question that I found on this, most of them has correlation and regression together. So there's no point giving you those ones now. I'm sure by the end of the class tomorrow, Saturday, we will be able to do that. So hopefully if we are fast enough, we'll start the line of best fit tomorrow. And we'll be able to do the least square regression line. It's just a bunch of calculations. Then you can solve past questions. If you're able to do those two tomorrow, that will be all right. Okay, line of best fits, least square. But we can't finish tomorrow because there is the regression of X against Y as well. So maybe we can include that in Monday's class, because I want you to practice in tomorrow's class as well. So by Monday, this should be done. Half of the Monday's class should be on the last parts before we move into the next thing. Somebody sent me a message already. Or is it got to that? This shows a very weak positive correlation. Very good. How is it got to that? There is a weak positive correlation. Wonderful. Wonderful. So it's as simple as that. How is it got to that? And there is a I think Miss V, so you are describing, so don't say R is equal to that value and there is a, no, it is the R that led to it. They are not different things. Do you get what I mean? So when you say R is equal to this value and there is a weak, no, it is the value that implies that. So they are not two different entities. So like someone put here, this shows exactly, you're commenting on it. Okay, very good. So there is a weak, yeah. So when you say, oh, R is equal to this value, which shows this, that. Miss K, I can see your calculator is very wonderful. But where is my comment? Miss, you're supposed to type in comments.
Typing.
Yeah, in the WeChat, that's what everyone is sending to me.
I'm still typing.
Or you can write it in your paper and just send to me. Brandy, what are you doing? I just told you not to plot scatter diagram. What is wrong with this dude? All right, that's okay. So I think we're all good with this. So this shows exactly, this is better now. Clary, thank you. Yeah, I know. Typo is inevitable when you're working on the phone. Okay, so this will be all about that for today, and I will send you pages of this book, and part of it will be your graded activity. Okay, the value of R shows yes. So I think we can all conclude that this is not something difficult. R is equal to Mr. Chang, your R seems to, oh, okay, this is for A. I asked you to do C. That's why I was confused, like, what is this dude doing? Ask you to do C. But anyway, so at least you know what we're talking about. That's what matters. So let's end the class now so that we can all go about our businesses. I hope this is okay to some extent to everybody. Yes? Okay, so I will send you some work to be done later. Some maybe on the drag and drop will be on, what's it called, on Edmodo. And anything to be done on worksheets, please find a way to print and, you know, maybe as I said earlier, maybe the first 2 pages will be sent to me, something like that. Okay, when we come back to school. Thank you very much. Happy New Year once again. Bye. Enjoy the rest of the day and keep yawning and eating, Miss Crystal. Okay, bye-bye.